Okay, let me see if I can share screen. I can't screen share when you're sharing.
Oh, okay. That's it. I could have allowed multiples, but it doesn't matter. I'll just stop sharing.
Can you see it?
Indeed, I can.
Okay, this.
Ah, right. Okay. This
Oh
looks
wait.
familiar.
I feel like these questions are flipped, as in the answer was for the bottom question.
No way,
Because
really?
I think so because it says while the system is moving, make carefully label free body diagram if the table is frictionless. But there's
Yeah.
like friction here, and then on the bottom question, it talks about frictionless, and there's no friction here. So
Well, careful. Scroll back up.
would that be the thing, or
Yeah. See, this is the table is frictionless, right?
but the block A
Uh,
wouldn't be frictionless,
yeah.
right?
There's friction between A and B.
Oh, but I'm also still confused. Why would the friction move to the right and not to the left?
Sure. So, you have think of the system first of all, huh? So if you pull on AB as a system, it has a certain amount of acceleration, huh?
Yeah.
So then you know that each block individually is going to be given amount of force to give it that acceleration.
Okay.
Think about it for a minute. So block A, let's say, I can let me. I can wonder if I can annotate the screen
I think you could.
when you're sharing. Yeah, it looks like it. Yeah, I'm the boss, so I should be able to do anything I want, right? So, anyways, if you have mass 1, 2, or well, sorry, AB. Ah, there we go. See, I added this. I made this. I found this setting yesterday about have the name of the person writing. I get it's kind of annoying though. I'll have to get rid of it. So that's MA plus MB, and then you have some force of the pull. So you're going to get some overall acceleration. A equals F over M, yeah. The pull over MAB.
Yeah.
All right, so then you look at what's the acceleration of B, or excuse me, what's the force that B gets by itself? It's going to be MB times AB. So it has some force on it. It's not equal to, um, give me a minute. Let's think about it. It gets a force just enough to give it that acceleration. Where does it come from? It comes from the friction of A and B, right? The only way I can apply a force to A is because that B and A have some connection to each other.
Okay. I think I'm starting to get it.
So this is the mathematical view, right? It doesn't
Yeah.
matter what's going on. You're told that this system is accelerating to the right. I
Okay.
have to assume, let's see. Yeah, move together as a unit. So B is not moving relative to A. Do you understand that part? Like,
Yeah. I understand that
okay.
they will move together, right?
Yeah, they're not. So A is not sliding. Now, the point is now, excuse me, that we know then we pull on this. Let's assume A is glued to B. Maybe that'll help you conceptually.
Okay.
If I glue A to B, I can we can get an acceleration of the system. Now, if I now just simply look at A, block A, so we make a free body diagram just for A, and we notice that A has some acceleration in this direction.
Oh, Give me a second. My parents are calling me.
Okay,
Give me one second.
no worries.
Okay.
You're
Getting back.
back.
Yeah.
All right. So as I was saying, we see some block, and we see that it's accelerating somehow. So we don't know about anything else except that we have block A, and it's on some surface, and it's accelerating to the right. So that tells us that there must be an F on A to the right here. And sure, there's probably a W, and there's probably a normal. Both are vectors. And so we can then figure out we know the direction, what's the magnitude of A, F of A. And when I said F of B here, I'm sorry, that's A, that might have been confusing. And so we can calculate it because we know it's accelerating at a particular rate. So mathematically, we know there has to be some F of A. And so when we go back to the system, we look at this and we go, where the heck could it come from? And the only place it can come from is from the friction of A on B or B on A, because friction is always two surfaces. So how do we think about this conceptually? So conceptually, remember that friction opposes what you're trying to do. So in this case, A wants to stay at rest. So friction has to pull to the right. That's all there is to it. Now, let's see, what else? So what's the other way to think about it? Block A is accelerating to the right. So right. The other day to think about this is that, right. So we know that block B is trying to accelerate to the right. And it's not achieving the acceleration that we expect. And what's happening is that this is being opposed by the friction of B on A on B. Is that right? Or is it B on A? Yeah, it's got to be an internal force, right? So it's the friction of A on B. Yeah, because it's external, A on B. So the what's happening is block A is imposing a force onto block B, and it's the friction, and it's not glue. I mean, in fact, the irony here is that glue and friction and glue both use van der Waals. That's the root of how they do their jobs is van der Waals force. Is this making it? Let's see. What's another way to think about it? Yeah, right. Of course, it is this because if I were to have some way, if I were to be peeking in at this system, let's say I'm peeking in on this system into a box. Well, now let's take into something like this. And all I could see was block B. And I knew the magnitude of this. So if I looked at this, F pull equals mass B times the acceleration, we expect the acceleration to equal F pull, boy, that's
Friction over
annoying,
mass.
over the mass of B. So we say to ourselves, well, hey, something's not right here. And so there's no such thing as a paradox. So if we see an apparent violation of Newton's second law, we have to like chip open the window into the box and we say, oh, that's because the mass is not mass of B, the mass is actually AB. And whether or not it's whatever is going on here, whether it's glued down or whatever, we just know there's an additional mass, so we don't get the same acceleration. So, but we can decide to look at it a different way if we want. We can decide that we know we want to have an A B, and so that means that we have an F on A and an F on B. And we should be careful and call it an F net and an F net. And so then we say, okay, what's the connection? Well, we wouldn't have any problem, I hope, if it was like this, then it would just be the tension, right?
Yeah.
Well, in this case, it just happens to be the friction, that's all.
Okay. I think I'm starting to get it. I think it makes a little more sense now, but I think I still need to review it a bit.
Yeah, this is one of those ones where it's kind of, you just have to, what I learned over time was just accept the what I did over originally here, accept the math, right? So the math gives us a certain answer, and the observation gives us a certain answer that we can't ignore because it's we see the reality, we do the calculation, and we know that the block is accelerating at a certain rate. We can't argue with that. Mother Nature never lies. So then if we just want to look at and then when we zoom in, what's the connection between blocks in A and B? And the only thing it can be is the friction between them.
Okay.
It's what happens is we're so familiar with glue or one block on top of another that we just don't spend any time thinking about it. And when we're forced to think about it, it's difficult. We sort of have to hit ourselves on the head a little bit. I suppose the idea is just like excuse me, the tablecloth, right? And the dishes and glasses. We have to jerk it really hard to make it work because we need to get the kinetic friction, for example, instead of the static friction. And there's other things like impulse and that sort of thing. But anyways, we know that works, right? What makes the dishes and the glasses fall? It's the friction between the glasses and dishes and the tablecloth. We just don't really think about it. So let's see. I don't know if you can screenshot this. If you like, I can. Oh, you can do your own type, right? Of course, because I know that it's built into Zoom. There you go. And then the recording will be available also.
Oh, okay.
Yeah, that's a good question. I have to make sure you guys can access these recordings. Probably I have to post it. So this is chapter 4.28. So I'm going to title the recording so other people can look at it.
I think for chapter 4, most of it I thought I think it was easier in chapter 5 definitely, but I think chapter 4 most of it was okay for me.
Yeah, chapter 4 should be easier because it's just simply introducing you to the ideas of the Newton's laws.
I think now that you explained part A, I think I'll be able to get part B.
Okay.
At least I'll want to at least try to get myself into that thinking.
Yeah, of course. I'll clear these drawings. and then it'll be easier to look at. Now I am going to, or I'm going to try anyway, to stop this recording because then
Okay, yeah.